since it is impossible to use the index, because I don't know if you want or not to filter, SQL Server will not use the index. Not use the index means scan the table, read every row in the table. Okay. And one of the solutions for that specific problem is to use the option recompile, the same option that we saw in the last demo. I created without the option recompile, okay, just to show you the issue. I ran the query, and the execution plan, it is basically scanning everything, reading every row, and to return your data. And but if I use that query hint, saying, hey, option recompile that query, then SQL Server can use the index, which is good, which is very good. Okay, and this is common. This is a lot of people know about this out there. But what I want to show you, it is a much hidden, as the name of the session says, it is a hidden problem. That in that case, even with the option recompile, it will not work. Let me show you. I recreate the store procedure with the option recompile, and then I'm going to call it again, and I'm still seeing an index scan. And what I was expecting here was an index seek using the index. And let me just show you the plan that I was expecting was something like this. That was the plan that I was expecting. Reading the B tree of the index, filtering by the value that I use. But even with the option recompile, it is not doing the index seek. And the problem is, it is a bug. Or, if you want to call it, a gap in the functionality, as a Microsoft like to call it. They used to say, hey Fabiano, that's not a bug, that's a gap. I had to agree with them, because a bug is when your application is not working, or it's returning wrong data. It is returning, it could be better, faster, but it is working. So I think it is a bug, but and it is just a bug. You have nothing to do unless rewriting the query to avoid the bug. And in that case, you could rewrite the query to avoid using variables. And the problem is with that. In the query, you are returning the count or something, or a column name or a column value to a variable, and then using a variable to something. And just because you are using it, SQL Server can't do the recompile and the index operation. And what I did to fix it was to put that result in a temporary table, and then read from the temporary table, put in the data in the variable. I'm showing the new query. So that's the final query. That's the same thing, but instead of using the variable here, I'm putting the data, I'm putting the data into a temporary table, and then I'm reading from the temporary table for the count. And it works. Let me show you the execution plan. Now, here it is, our seek. So what I'm showing you here is that if you had a table with 1 million rows, it would take a lot of time to read all of the rows. And that could be 1 minute query. And now with the seek, 0 seconds. It could be like this. I have this query taking 10 minutes to finish. With that kind of treaty optimization, you could run the same query in 0 seconds. Okay? Good. Hash. Let me see about the time. Yeah, I'm going to show you the first the sort, and then let's come back to the hash. Okay. Let me make sure that everything is right. Okay. Let's create one small table here. Okay. So I have this products big table with, I think it is 10 million rows. And I have this query filtering by the product ID, which is the primary key, which I already have an index. And I want just the product IDs between 1 and whatever is the number, 2747. Okay? Good. This is the query. But there is an order by clause. And I'm asking the same data ordered by some call, which is the call test. Okay? So let's check the execution plan. Sorry. The execution plan again is pretty straightforward. So it is seeking data from the index in the product ID, which is the primary key, and then sorting the data by the call test. But we can see in the execution plan one thing here, one interesting thing. There is this cost operation. And just by looking at it, we could see that the most expensive operation in that query is the sort, which is 73% of the whole query. Okay, I'm taking 73% of the whole time just to run that sort. But the problem here is that that sort could be good, or could be bad, or very bad, or very, very bad. And I will show you. Okay. So it is already bad because it's taking 73% of the whole time. But if it's running in memory, then it is not that bad. What do you mean by in memory, for example? I mean, SQL Server will read all of the rows from between 1 to 7, the number. So let's suppose it will return 2,000 rows to the sort. Then with that 2,000 rows in memory, the algorithm sort will run and sort the data and then return your query. But the problem is when that 2,000 rows doesn't fit in memory. You don't have memory enough. Oh, but 2,000 rows, in that case we can see the size of the row. It is less than 1 megabyte. Yeah, it is actually 5 megabytes of data. I definitely have more than 5 megabytes of memory in my laptop. But the problem is that sometimes SQL Server, the way it works, it just don't ask for more memory. Here is how it works. Before start executing the query, SQL Server will reserve some memory to run that query. And depending on how much SQL Server reserve, could be enough, it could be not enough. In that case, it is not enough. And you see that it is running, it is going to the disk. Because when you are running sort, which doesn't fit in memory, SQL Server will start to write it down to the disk and then run the sort operation there, which is much slower than process everything in memory. And this is just how the way it works. SQL Server, the process is called the memory grant. It just doesn't grab memory enough to run your query. And when that happens, it will go to the disk. And when it goes to the disk, it is very, very slow. And I will show you. How do I know it is running in memory or not? On SQL Server 2012, you can run the query and look at the execution plan, and notice now that there is a warning icon here. And that warning means, hey, I did the sort operation in disk. And this is good, but this is not good. Definitely not good, not good. But hey, Fabian, but the query is running in 0 seconds. It's fast. Let me run again. I'm running, and I'm not seeing any performance problem here. Yeah, kind of. What if you run the same query in production? Because I'm running on my laptop, and on my laptop, I'm the only one running it. What if when I put in production and a lot of users around the world start running the same query? What then? I will try it. And there is a very interesting tool that I really like it. It is called the SQL Query Stress. And the idea, that's tool, by the way, SQL Query Stress, it is a free tool. You can download it from the internet, okay? And the idea is, there is a query that I want to run 5 times, simulating 100 threads. So what I'm doing with that tool is I'm opening 100 sessions and running the same query 5 times on each session, all at the same time. I'm kind of simulating the production environment, right? And now let's run it. And let me show you something. It is using a lot of resource out there, and it is still running. Okay, that doesn't look like it is good. Let me cancel. And let me run the same query, but now using a trick thing. I'm showing it here. Here's the trick. To ask SQL Server to grab more memory, I'm kind of fooling it. I'm lying here. I told SQL Server that the value for that variable is 5,000. But in fact, we saw there, which is the same value, 27447. But SQL Server doesn't know, because now I'm using the variable. And since I'm using the variable, SQL Server doesn't know what is the value inside the variable. And I'm kind of giving a tip here. Hey, SQL Server, the value of that variable optimize for 5,000. So now SQL Server thinks I'm going to return more rows. And since I'm going to return more rows, I will need more memory. Okay? And then the memory that SQL Server grabs, it is enough to run in memory. Let me show that execution. And now there is no warning anymore. It is still taking 0 seconds. But let's try that query in the SQL Query Stress. This is the same query, okay? I'm going to just go and run it. Whoa. Okay, I just ran 5,000 iterations. It took 1.2 seconds. Oh, what about with the warning? With the sort being written to disk? We saw that. I ran it and it took a lot of time and didn't run any one. I will run it again. That's the query with the warning. In other words, running the sort in disk. Still running. It will take a lot of time. And why? My disk is crap. I have 2 disks in this laptop. One SSD and a mechanic disk. And let me show you. Here again on the resource monitor. Here, I'm writing 17 megabytes per second. And for each write operation, I'm taking almost 3.4 seconds. That's way too much. That number we want to see is close to, in the worst case, 30 milliseconds. Never 3 seconds. So that number should be always close to 1 millisecond, up to 15 milliseconds. 3 seconds is ridiculous. And that's because my disk is, yes, it is not that good. But I have an SSD, and I'm going to change the temp.db, which is the file SQL Server used to write that internal operations, to the SSD. So it is still running, okay? 1 minute, and it's still running. And that's where everything starts, with the developer saying, in my machine, it works. Yeah, try in production with a lot of users running at the same time. So let me change the temp.db to the SSD. Okay, let me see. Okay, come on. Okay, I read there. So same query running, okay. Now I will run the same query with the warning, or in other words, going to the disk. But now I have used a better disk. Let's see. Yes, it is still slow, but now it is at least running. Compared to running memory, it's way different. But now at least it's running. And if just in case you want to know, I was writing 73 megabytes per second. Now I'm writing. Before I was writing 17, I think, right? And now I'm writing 10 times more. And still with an SSD, the response time is higher. But it is because just I'm using a lot. Okay. Yeah, and this is interesting, isn't it? And that's why you have to put your temp.db in the best disk ever. Okay, because your temp.db is important. That sort operation is reading to the temp.db, and the temp.db has to be in your best storage environment. Okay? Good. Already done. 23 seconds. In my very slow disk, it was running for almost 2 minutes, and wasn't there. So I still have a few demos that I wanted to show you, but I don't have time. But I will leave the scripts here, and you can try it by yourself. And in the scripts you have, in the end of the script, you have some references about the topic, so you can read more about it. In that case, the Bushy plans, I wrote an article about it. You just go follow the links and read more about the subject. And I told you that I wanted to leave a few minutes to questions, and we still have, how many? 1 or 2? Probably 2 minutes. So if you have any question, it could be not related to the topics I had shown to you today. If you have any performance problem that I want to bring up, we should be comfortable to it. Anyone? Otherwise, we will finish our session. No? I will be here for a couple of minutes, so if you want to come and ask something to me, feel free to do it. It's again, it's a real pleasure to be here, and thank you. I hope to see you soon later. Okay, bye.